Hello, students. Today we'll be discussing Chapter 8, Production and Operations Management. Our learning objectives today are very concise. We'll describe the current state of U.S. manufacturing and what manufacturers have done to become more competitive. We'll describe the evolution from production to operations management. We'll identify various production processes and describe techniques that improve productivity, including computer-aided design and manufacturing, flexible manufacturing, lean manufacturing, mass customization, robotics, and 3D printing. We'll describe the operations planning issues, including facility location, layout, materials requirements planning, purchasing, just-in-time inventory control, and quality control. And we'll talk about the use of PERT and Gantt charts to control manufacturing processes. A little bit of background. In 1979, nearly 20 million people worked in manufacturing. About 12.5 million people worked in manufacturing in 2021 in the US. The value of products made in the US continues to reach a record high. This is due to technology and automation changing the types of jobs people do. Now in the US, about 80% of jobs are focused in the service industry. This means that the manufacturing has become so productive that fewer workers are needed. Robots. Many modern robots can safely work side by side with humans, and in some cases have replaced the human role completely. Some of the things that are made in the US include chemicals, pharmaceuticals, cosmetics, soaps, paints, and fertilizers, computers and electronics equipment, processed foods, beverages, and tobacco, and transportation equipment such as vehicles and parts manufacturing. The photograph pictured shows a Chrysler 200 sedan. And as you can see, parts from the sedan come from all over the world. However, it carries the slogan America's Import. About 67% of this particular vehicle was made in America, and the final assembly was in Michigan. So, just to answer the question, that it's made in America, possibly just assembled in America with parts coming from all over the world. So, as computers manufacturing organizations have become more competitive, other countries have increased in competition, namely places like China and then other iconic countries such as Germany. Innovation is not exclusive to the US. So, how can the US maintain a competitive edge over these other growing economies? They can focus on our customers, maintain close relationships with suppliers, practice continuous improvement, which we'll discuss later, have a specific focus on quality. It is important to note that quality from other countries such as China have improved dramatically over the past 20 years and is now close or indistinguishable from the US manufacturing quality. Um, Cost savings through site selection and other opportunities to gain a competitive advantage is important. And strengthening the manufacturing base, the United States will have to innovate to be able to continue to be competitive. Some manufacturers that are located in the United States include Apple Computers, Petroleum from ExxonMobil, Computers and Electronics from Microsoft, and many vehicle manufacturers such as Ford, GM, and Toyota. And yeah, there's a number of petroleum locations as well. So going from production to operations management. The definition of production is it is the creation of finished goods and services using the factors of production, land, labor, capital, entrepreneurship, and knowledge. Production management refers to all activities managers must do to help their firms create goods. Operations management includes inventory management, quality control, production scheduling, follow-up services, and more. This slide discusses how AI has revolutionized the service sector for operations management. Can you think of different ways AI has been used to better serve customers? Through the use of machine learning, we can better adapt to and quickly address customers' changing needs and interests. We have analyzed social media and other platforms to try to understand some of the drivers for customers' preferences. And as AI is constantly evolving, we are using that language learning models to improve the quality of data and be able to better use that data in the business environment. Operations management for service is focusing on the customer experience. For example, in a hotel, business travelers have specific needs and require office-style support. What kinds of amenities do you think hotels should provide to attract business travelers? I would agree if you would say fast internet, an office-style environment, printing capabilities, and so on. So how has manufacturing changed in the United States over the last few decades? Labor has transitioned from large quantities of well-paid workers with low skills working on the assembly lines to largely automated procedures with a few highly skilled engineers running the lines. What must American companies do to remain competitive? To remain competitive, American companies will have to continue to innovate. This includes quality, customer service, technology, lowering costs, improving efficiency and effectiveness, and so on. How does operations management differ between the manufacturing and service sectors? Manufacturing focuses on scale and productivity. Services must focus on quality and customer perceptions of value. Within the production process, there are different ways to add value to materials or processes. One is through form utility. Form utility is the value producers add to the materials in the creation of finished goods and services. Process manufacturing changes the materials either chemically or physically. The assembly process is part of the production process that puts together components. The continuous process is a production process in which long production runs turn out finished goods over time. Intermittent processes are processes in which the production run is short and the machines are changed frequently to make different products. So let's take a look at form utility. Form utility works by assuming that a customer can see value in a finished version or form of a product rather than in individual parts. For example, customers can perceive an increased value from a scarf rather than a collection of yarn because they can wear the scarf and use it to keep warm. They may also perceive increased value because it could be challenging or time-consuming to assemble the product on their own. While individual components of a product are necessary to create a finished whole, form utility depends on the final version's ability to meet customers' needs. Consider the process of form utility in producing a cake. Form utility is the value producers add to materials in the creation of finished goods and services. So we're going from raw ingredients to producing a wedding cake that has utility in a celebratory setting, and then can be consumed or be eaten. The assembly process is the part of the production process that puts the components together. A continuous process would be long production runs turning out finished goods over time. Think producing several wedding cakes in one day as opposed to a single one. The intermittent process um, would have a production run that is shorter and change the machines frequently to make different products. So we might go from producing cakes to producing pancakes and then changing over to a third form. So the production process takes the initial input, adds in productivity through labor, capital, knowledge, and facilities to produce an output in the form of goods, services, or ideas, which can then be sold to the customer. All right, this slide presents the production efficiency of various products. How many Krispy Kreme donuts or Chips Ahoy cookies do you think are made every minute? Here you can see in a minute, it creates 5,208 Krispy Kreme donuts and 4,000 Chips Ahoy cookies. So the production efficiency can directly translate into cost savings and therefore profits, since we're able to produce more in a shorter amount of time. All right, going into different types of production processes. So the overall goal is to produce high quality goods and services in response to customer demand. This can be done through the aid of computer-aided design and manufacturing, computer-aided manufacturing. Um, So computer-aided design is the use of computers in the design of the product. The computer-aided manufacturing is the use of the computers in the actual manufacturing of products. Flexible manufacturing is designing machines to do multiple tasks so they can produce a variety of products. And lean manufacturing focuses on using less of everything compared to mass production. Mass customization, in turn, is tailoring the product to meet the needs of large numbers of individual customers. Types of flexible manufacturing might be done with 3D modeling, 3D wax, casting, assembling, stone setting, and polishing. Material handling moves from one station to another, and it is controlled by a central control system. An iPhone is an example of flexible manufacturing since it can come with different storages, sizes, and different colors. In terms of mass customization, we're tailoring products to meet the needs of large numbers of individual customers. I've coined the term made to order or build to order. For example, Nike offers a program called Nike ID that lets customers choose the color, material, cushioning, and other attributes for athletic shoes. Dell pioneered custom configured computers, whereby customers pick their computer's processor, memory, storage, and other equipment when purchasing on Dell's website. Dell's entire supply chain and distribution system is optimized to provide customers with direct access in a way that reduces Dell's operating costs while improving responsiveness. So, computer-aided design and manufacturing, it has changed a lot of production techniques. We now use 3D modeling to, instead of having prototypes made, which can involve multiple iterations and a lot of waste. Computer-aided manufacturing is now, we're now able to use 3D printers for CAM. For example, you can 3D print an entire house or a bridge, for example. Uh, Computer integrated manufacturing uses both CAD and CAM in design and production. So flexible manufacturing, as we talked about before, can do multiple tasks. In contrast, lean manufacturing uses a minimum amount of human effort, strives to reduce the overall manufacturing space, invests in tools and in engineering time. Compared to others, lean companies tend to take half of the human effort of non-lean companies. They have half the defects in finished products. They require roughly one-third of the engineering effort. and can use half of the floor space. They also tend to carry 90% less inventory, which translates to lower inventory holding costs. In lean manufacturing, they focus on 8 different types of wastes and try their best to reduce them. And through continuous improvement, look for new ways to continue to reduce waste on all areas of the manufacturing process. For example, they try to reduce the number of defects or rework so the defects are not thrown away. They try to time manufacturing to avoid overproduction. They try to have their manufacturing floor fully staffed to reduce waiting times and also make sure inventory arrives on time. They strive to reduce non-utilized talent, which might be individuals standing around on the manufacturing floor or not having a purpose or utilization at a given time. They want to lower transportation costs, which might mean having the facilities closer to the inventory areas or reducing transitions in transportation. They want to minimize inventory, minimize the number of repetitive motion that happens throughout the process, and reduce extra processing of equipment, which comes from manufacturing variations. In Lean, they also use the principle of 5S. Here I've written the Japanese translation as well, but I'll go over just the English ones. So the 5S includes sorting, setting in order, shining, standardizing, and sustaining. This means that you will sort the information, whatever materials you have. Think about an office situation where you have a desk with messy papers everywhere. The first thing you want to do is sort those papers. And secondly, you will set them in order, perhaps in the work order that you need to process through those papers. You will organize them according to a methodology. Then you will clean the area, which in this example would be dusting the desk, the chair, vacuuming, and making sure everything quote unquote shines. Then you would standardize. This means having a repeatable process, in this case in your work area, so that, for example, papers could stay on the left, writing materials would stay on the right, and materials that are not used as often might be kept in a drawer. Standardizing also helps, you can outline with 5S tape, so it becomes obvious if a tool is missing. Lastly, you would sustain. That means continue to keep everything in order, continue to make the process work. If something doesn't work, then you would go back to re-standardizing and then sustain your process going forward. You can think about the different types of waste that this reduces in the lean manufacturing process. For example, if you're always reaching for the same tools, you might want to have those on top of your desk and within reach. For tools that you use less often, you may keep them down in a drawer. Imagine you have a tool that you use often that you put in a drawer. That would require you to bend down, open the drawer, take the tool out, close the drawer, and then open and close the drawer again when you're done with it. This in lean manufacturing is considered wasted effort. In robotics, robotics has drastically improved productivity and reduced the number of human jobs. If you go back into the PowerPoint slides, you could click on this Amazon link and it shows you the process of using robotics on Amazon's pick and place in their warehouses. So 3D printing, you can use additive manufacturing. Using sensing, measurement, and process control requires data control sensors and can utilize nano manufacturing. For 3D printing, the bridge in the picture below has been 100% 3D printed. It's an 85-foot concrete bridge in Shanghai. Can you think of any other structures that might be able to be 3D printed? All right, we'll go over these and you can review these on your own time. Let's move forward. For facility location, we want to make it easy for customers to use the company's services and to communicate their needs. Rising number of online businesses mean brick and mortar retailers need to find great locations and provide outstanding services. Since COVID, as we are moving sales more and more online, having a facility location and having warehouses that have products nearby, or if they're coming from overseas, housing them in a warehouse in the United States has become necessary for quick ship operations and for customers to get the materials they need faster and in a lot of cases on time. For example, in this state, it is roughly a week before Halloween. If we wanted to order something, it would need to be able to arrive in the next 3 to 4 days in order for us to utilize the product for Halloween. If something is manufactured overseas, it would need to be temporarily stored in the U.S. warehouses around Halloween time to ensure that their products are purchased and arrive in time. Okay. For location for manufacturers, some considerations can be labor cost, resources, access to transportation, proximity to customers, crime rates, and housing stock. In the photo pictured below, the photo shown above is in San Francisco and also occurs frequently in Los Angeles, where shoplifting misdemeanors under a 900 is considered a misdemeanor if the value is under $950. This has sparked a lot of crime and petty theft in these urban areas where individuals will run in, grab a bunch of materials from the store, and run out quickly. Um, Having a sales location in one of these areas might not be favorable due to the rate of crime. Other considerations can include the quality of life for employees, cost of living, or need to train or retrain the local workforce. All right, more about facility location. So it might take into consideration the availability of qualified workers. You might need access to transportation, suppliers, or customers. This might be one reason why the manufacturing facility is located directly on the water. As you can see, it has close access to the train depot and the possibly suppliers that are coming en route from other countries. It is also located near a large city, which might give an availability of qualified workers. All right. And interfirm operations. This may include outsourcing some components of the operations process, including the engineering, design, manufacturing, or other tasks. So, IT makes telecommuting a major trend. Telecommuting is working from home via computer. This reduces the need for companies to locate near sources of labor, since individuals will not be having to drive in to go to work. All right, another example of facility layout is pictured below in the office environment. So this office plan helps the employees maintain social distance and they limit the number of people in each room and provide plenty of space between desks. Do you think open office plans are an effective way to keep workers safe and productive? All right. Some of the some of the methodologies used and facility layout can be an assembly line layout, where a few tasks are done at a time, and the product is moved down the assembly line. A modular layout can have teams of workers that produce complex units. A fixed position layout allows them to congregate around the product. And a process layer playout is similar, and equipment and functions are grouped together, similar to an assembly line layout. For example, the assembly line layout that is shown below in an activity on node diagram has the storage, cutting, and then to a burst activity where the product can go through stamping, deburring, and bending, and then through assembly, or it can go straight to assembly and then to packing and shipping. So this may depend on whether or not they're selling components as opposed to selling the entire module together. All right, not to be confused with the modular layout or cellular layout that can accommodate changes in design or customer demands. The fixed position layout requires that workers' supplies and inventory comes to one central location. A good example of this is building a house, where everything needs to come to the house in order to manufacture the product to bring it to its final stage. Material requirement planning. This is a computer-based operations management system that uses sales forecasts to make sure that needed parts and materials are available at the right time and place. Materials requirement planning can kick in when stock quantities are low, for example, and automatically order more quantities of that product type. ERP or Enterprise Resource Planning is an integrated software program that uses one single database. This means that it has one form of knowledge and updates that for the entire company. This results in a shorter time between orders and payment, less staff needed to do order processing, reduced inventories, and better customer service. So if you decide to pick something out of inventory or out of stock, then um, any other area in the ERP system will know about it because it has one source of truth or one source of knowledge. In the ERP, a newer version of materials requirements planning that it's a newer phrase than using MRP. MRP is a partial solution and is a subset of the enterprise resource planning process. So the ERP combines all the activities of the firm, including finance, HR, order fulfillment, in addition to the operations management. So all of those functions can read off each other and can use the same information. For example, if you're scheduling an individual to work on a specific assembly line on the manufacturing floor, finance can see that from cost perspective, HR can see that from a staffing and allocation perspective, and engineering can see it from a production operations management perspective. All right. So purchasing. Purchasing is the function within the firm that searches for quality material resources. It finds best suppliers and negotiates the best price for goods and services. So a company may use several suppliers, and just-in-time inventory control will keep the inventory on the premise and parts, supplies, and other items that are needed just in time for the assembly line. So if the production schedule is accurate using the ERP system, then the just-in-time inventory will trigger and allow the right parts to be in the right place at the right time. Quality control. So what is quality? Quality is consistently producing what the customer wants while reducing errors before and after delivery to the customer. Statistical quality control is the process some managers use to continually monitor all phases of the production process to ensure quality is being built into the product from the beginning. And the statistical process control is the process of taking statistical samples of product components at each stage of the production process and plotting those results on a graph. Um, Any variances from quality standards are recognized and can be corrected if beyond the set schedule. Six Sigma quality. That's a quality measure that allows only 3.4 defects per million opportunities, which represents 6 standard deviations from the mean. This means an accuracy level of 99.9997% or better. In 2005, Motorola attributed over $17 billion in savings to Six Sigma. All right. So some of the governing authorities over the operations management planning process is ISO 9001. That's the common name given to quality management and assurance standards. Um, the ISO 9001 is used stateside, while the European Union uses ISO 9001 standards. They're required, while it's optional in the United States. ISO 14001 is a collection of the best practices for managing an organization's impact on the environment. It does not prescribe a performance level. It's an environmental management system to continue to progress and to improve environmental standards within an organization. All right, we're going to move on. I'll leave these test prep questions for your individual review. Discussing the PERT technique. So PERT is a method for analyzing the tasks involved in completing a given project, and it estimates the time needed to complete each task and identifies the minimum time to complete the entire project. All right, it was originally developed in the 1950s for constructing nuclear submarines. The users analyze the tasks to complete the given project, estimate the time needed to complete each task, and compute the minimum time needed to complete the whole project. So you would use the following steps to create a PERT. You would analyze and sequence each task in the process. You would estimate the amount of time needed to complete each of the tasks, and you would draw the PERT network illustrating the first two steps. Then you would identify the critical path. In the PERT network, the sequence of tasks that takes the longest time to complete is the critical path. For example, in the PERT diagram, you can see that we are creating a music video. From the start, it takes 1 week for the star and the song to be chosen. This is definitely on the critical path because in order to start, we need this first module completed. From then on, we have two separate work streams that are coming from this start time. So it takes 4 weeks for the set to be designed and 3 weeks for the costumes to be designed. I'm sorry, there are 3 burst activities. So the dancers are also selected at this time, which takes 2 weeks. From the set design route, we are going to purchase materials, construct the set, and then the dancers will rehearse in it, and then the video can be filmed. From the dancer activity, they are first selected. The dance is choreographed. They learn the choreography, and then the dancers rehearse in the constructed set, and the video can be filmed. From the third path, we're designing costumes, measuring the dancers in those costumes, creating the costumes, and then the dancers will wear them on the constructed set before the video is filmed. So the critical path is the minimum amount of time it will take to produce the video. So you need to add the week it takes to pick a star and the song to the 4 weeks to design a set, the 2 weeks to produce set materials, the 6 weeks to construct the set, the week of rehearsals, and the final week when the video is made. That's the critical path. Any delay in that process will delay the final video. Similarly, a Gantt chart can be used as a different type of graph. It's a bar graph, which shows the production managers what projects are being worked on and what stage they're in at any given time. Here's an example of a Gantt chart for a doll manufacturer. As we can see, different work processes are happening at different times, but the heads and bodies need to be molded before the fabric can be cut and the clothing sewn. Lastly, they can go on the assembly line for assembly and painting. You can also see the amount of progress that has been done. So we can see not all of the heads have completed molding, but the bodies are all molded. So once we're done completing the heads, we can move on to cutting fabric. As an exercise, you could draw a PERT chart for making a breakfast of 3-minute eggs, buttered toast, and coffee. Then you could define the critical path. So you would need to break down the components, estimate timing for each of the components, and set them in order, and then find the longest duration of time, which in the longest path, which can determine the shortest overall completion time for the breakfast. You can also think about how you could use a Gantt chart to keep track of overall production. Think about different types of manufacturing and different production components that can be used similarly to the doll making process in the last slide. That's all we have for today. Thank you.